ROC-AUC, short for Area Under the Receiver Operating Characteristic Curve, and Precision-Recall AUC, or Area Under the Precision-Recall Curve, are both important model evaluation metrics. The key is that they describe performance from different angles. ROC-AUC tells you about separability across thresholds, and Precision Recall AUC, on the other hand, tells you more about the quality of positive predictions, especially when the positive class is rare. And that distinction turns out to matter a lot in real systems. In this video, we cover three things: what ROC-AUC tells you, and what PR AUC tells you, and how to choose between them based on how the model will actually be used. Before we get into ROC curves or a precision recall curve, it helps to start with a simpler question. What decision is this model actually supporting? Are you ranking cases so a team can review the highest risk few? Are you making a binary decision at a fixed threshold? Are false positives relatively harmless, or do they create real operational cost? And is the positive class rare to begin with? Those questions matter and help you decide which metric to use for evaluation. ROC-AUC and Precision Recall AUC tell us different things about the predictions being made by the model, and they're not interchangeable. Most classification models do not start by making a hard yes or no decision. In a classification problem, the positive class is simply the outcome the model is trying to identify. For example, fraud, churn, disease, or click. They usually assign each example a score, sometimes interpreted as a confidence or probability, that reflects how likely it is to belong to the positive class. To turn that score into an actual prediction, you choose a threshold. Above that threshold, you predict positive. Below it, you predict negative. And that threshold matters. If you set it high, the model becomes more conservative about calling something positive. If you lower it, the model becomes more permissive. So when we evaluate a classifier, one important question is not just how it performs at one threshold, but how its behavior changes as we move that threshold up and down. That is the context for ROC-AUC. So let's start with ROC-AUC, what it measures well, and why it can still be incomplete in imbalanced settings. ROC-AUC measures how well the model separates positives from negatives across all possible classification thresholds. The ROC curve plots the true positive rate on the y-axis and the false positive rate on the x-axis. So ROC-AUC answers a ranking style question. If I sweep the threshold from very strict to very lenient, how well does the model distinguish positive cases from negative cases overall? That makes ROC-AUC useful because it is threshold independent. It does not force you to pick one operating point too early, and conceptually, it is measuring separability. A high ROC-AUC means the model is generally better at ranking positives above negatives. That is genuinely useful, especially early in model development, where you want a broad sense of whether a model is learning the signal. But here's the catch. ROC-AUC uses false positive rate, not the raw number of false positives. And false positive rate is normalized by the number of actual negatives. So, if you have a massive negative class, which is common in enterprise settings, you can accumulate a lot of false positives while the false positive rate still looks deceptively small. That is exactly why ROC-AUC can look strong even when the model would create operational pain in production. Precision Recall AUC focuses on a different trade off. The PR curve plots precision on the y-axis and recall on the x-axis. Precision asks, of everything the model predicted as positive, how many were actually positive? Recall asks, of all the real positives, how many did we catch? This becomes especially important when positives are rare, because in that setting, you would care whether the alerts, flags, or positive predictions are trustworthy enough to act on. That is what precision gets closer to. If your fraud model sends 1,000 alerts and only 20 are real fraud cases, the model may still achieve a reasonable ROC-AUC. But operationally, that system may be terrible. Investigators get overwhelmed, trust in the model drops, and the workflow breaks. PRAUC is much more sensitive to this reality. When the positive class is rare, PRAUC typically gives you a more honest view of whether the model is useful where it matters, among the cases you're actually calling positive. That is why, in highly imbalanced problems, PRAUC often aligns better with what stakeholders actually experience. Not because ROC-AUC is wrong, but because it is answering a different question. A subtle but important mistake is stopping at AUC entirely. In production, nobody deploys all thresholds. You deploy one threshold or maybe a few operating points. So even if ROC-AUC or PR-AUC is your summary metric, you still need threshold level evaluation. What is the precision at the top 1%? What recall do you get at the review capacity your ops team can actually handle? How many false positives per day does that create? What is the downstream cost? That is where model evaluation becomes decision evaluation. You have to stop asking only if the model is statistically better and start asking if the operating point is systemically viable. ROC-AUC matters when you care about overall ranking quality across thresholds. It is useful for model comparison, early stage development, and cases where class imbalance is not extremely distorted or where false positive load is not the dominant operational pain. Precision recall AUC matters more when the positive class is rare, or you care about the quality of positive predictions, or false positives are expensive operationally. Humans or systems act on a limited set of top ranked cases. And that covers a lot of important real world enterprise systems. So the practical answer is not always use PR AUC or never use ROC AUC. Use ROC AUC to understand separability. Use PR AUC to understand usefulness under class imbalance. And choose your primary metric based on the actual deployment decision. For different scenarios, here's the decision rule I'd remember. If positives are rare and the cost of false positives is real, make precision recall AUC your default headline metric. If you're evaluating general ranking ability across thresholds, keep the ROC-AUC in the picture. And if you're close to deployment, neither of them is enough by itself. You also need threshold specific metrics tied to the workflow. That framing is simple, but it prevents a lot of bad model storytelling. I hope this helped you understand how ROC-AUC and PR-AUC measure different things. Please subscribe to Schovia and as always, stay curious.